Hi there, today I'm going to go through Edexcel's A-Level Maths Mechanics from October 2020. First of all, it's a sort of a classic problem of an object on a plane. So let's just draw a quick diagram of this. So we're told that we've got a plane which is inclined at an angle alpha, where tan alpha is 3/4. We've got some object P, which has a mass of m, so that means it has a weight of mg. And the coefficient of friction is mu. So first of all, what we've got to do is find the normal reaction force, which is this one here. So whenever something's on a plane, the best thing to do is to resolve the weight into two components, one acting parallel with the plane and one acting perpendicular to the plane. So this mg, we're going to take one component perpendicular, normal to the plane like that, and one component parallel. Now, if this angle here is alpha at the bottom, then this angle up here is also alpha. Okay, so that means that this side here is mg cosine alpha, and this one is mg sine alpha. Now, a little thing that they often do on these exams is they tell you the tangent of the angle, or the sine or the cosine of it, and they seem to be quite fond of Pythagorean triples. So if tan alpha is 3/4, let's just draw a quick diagram of that. So remember, the tangent of an angle, one of probably the first things you ever learn in trigonometry, is that tangent is opposite over adjacent. So that means that this is equivalent to a triangle which has an opposite side of 3, an adjacent side of 4, and therefore we can just use Pythagoras to work out that the other side must be 5. 3 squared plus 4 squared is 25, square root is 5. And once we do that, we can write down the other trigonometric function. So we can see that sine alpha is opposite over hypotenuse, so that's 3/5. And the cosine of alpha adjacent over hypotenuse, so that's 4/5. Okay, so let's add these to our diagram. So we can say that the component of the weight acting into the plane is just 4/5 mg, and the component acting parallel is 3/5 mg. Right, now that we've got a diagram, we can answer these other two questions quite quickly now. So find in terms, one more thing, it's a rough surface, so there'll be a force which is acting up, a frictional force, F, which is equal to mu times R. Okay, and R is the reaction force, so let's do this. So find in terms of m and g the magnitude of the normal reaction of the plane on brick P. Okay, so if we resolve it in that direction, we've got R acting out of the plane minus 4/5 mg acting into the plane, and it's not moving, so you have to be equal to 0. Okay, so R is equal to 4/5 mg. Okay, so that's question 2 done. Sorry, part A done, so 2 marks. And then the other bit, show that the coefficient of friction is 3/4. Well, let's resolve it in the other direction now. So up the plane, we've got F, which is, well, we'll just write F at the moment, minus the force acting down the plane, which is 3/5 mg. But we know that F is equal to mu times R. So we've got mu multiplied by, but we know what R is, it's 4/5 mg, we worked that out in the first part. So we've got mu times 4/5 mg minus 3/5 mg equals 0. So if you rearrange that, you get mu is equal to 3/5 mg divided by 4/5 mg equals 3/4. We're now told that brick P is removed from the plane and a much heavier brick is placed on the plane. Okay, so the mass has changed. The coefficient of friction is still the same, so explain briefly why brick Q will remain at rest on the plane. Okay, so remember that the force acting up was mu times 4/5 mg, and the force acting down was mg sine alpha. So what we can say is that both forces depend on mass in the same way. Okay, it's just linear with the mass. So therefore the forces are still balanced. And then the last part, describe the motion of brick Q, given a reason for your answer. Okay, so this time we're told brick Q is now projected down at 0.5 meters per second. Okay, so the forces are balanced. So there's no acceleration. So therefore Q moves at a constant speed of 0.5 meters per second. Okay, so whatever speed you set it off, it just continues at that speed because the forces are balanced. Okay, so that's question 1 done. Okay, question 2 is about the motion of a particle. So we're told that a particle P has an acceleration of 4i minus 5j meters per second squared, and at time t equals 0 it is moving with a velocity of minus 2i plus 2j. So this is the initial velocity. Then if t is 0, this is the acceleration, and we want to find the velocity after 2 seconds. So that's going to be my v. So we're just going to use suvat here, but the vector version of it. So v is going to be equal to u, which is minus 2i plus 2j, plus a, which is this, and then t is 2 seconds. So if we put that all together, we've got minus 2i plus 8i, so that's 6i, and then we've got 2j minus 10j, so that's minus 8j. Okay, and that's it, that's the velocity. If we were asked to work out the speed, we'd use Pythagoras, but we're not asked to do that here. Right, so we're also told at t equals 0, P passes through the origin, and at t equals uppercase T seconds, the particle P passes through point A. And we're told the position vector of point A. So find the value of t. Well, what we need to do then is we've got the acceleration, we've got information about the position vector and the velocity, so we need to integrate twice. So first of all, we know that that's true, that the velocity is the integral of the acceleration. So we integrate 4i minus 5j, and we get, so 4 and 5 are just constants, but also the I and j, they're just constant vectors. So we just treat them like constants when we integrate. So all we're going to do is multiply each of these by t. So we get 4t in the I direction minus 5t in the j direction. Okay, and then plus a constant, I'll call that c1, but that's a constant vector. So what do we know? We knew that at t equals 0, the velocity was minus 2i plus 2j. So we're going to use that piece of information in here now. So we get minus 2i plus 2j for v. We substitute in t. That means that both of the first two terms, the 4t and the 5t, cancel. So we get straight away that that's the expression for c1, 2i plus 2j. Minus 2i plus 2j. Okay, so So v is that. Let's just write it in full. So let's group the I bits together. So we've got 4t, and then we've got another minus 2 from the constant. So we've got that in the I direction, and then we've got minus 5t plus 2. So let's write that as 2 minus 5t in the j direction. Okay, now we need to integrate again. So r, the position vector, is the integral of the velocity. So let's do this. 4t integrates to 2t squared, and 2 minus 2 to minus 2t. 2 integrates to 2t, and then minus 5t becomes minus 5t squared over 2. Okay, so simple integration, and then we get another constant vector of integration. So what else do we know? Well, we're now told that when t is equal to uppercase T, well, hold on, first of all, sorry, we use this piece of information. So when t is equal to 0, it passes through the origin. Okay, so we've got t equals 0 when r is equal to 0. So we're going to use that in here now. So 0 is equal to, and again, these two terms all vanish because they all depend on t like that. So you just get that this second constant is just equal to 0. So r is equal to 2t squared minus 2t I plus 2t minus 5t squared over 2j. Right, so at time t equals t seconds, it passes through A. So we're going to use that piece of information now. And there's A, lambda I minus 4.5j. So we're going to substitute that in. So we get lambda I minus 4.5j is equal to, and I'm just going to substitute uppercase T in here. Okay, so I've just substituted that into the position vector equation. So I get two equations now. If I look at the two components, the I component and the j component, for the j component, I've got on the left hand side minus 4.5, and on the right hand side I've got 2t minus 5t squared over 2. So if I rearrange that, so I'll move the 5t squared and the 2t to the other side, and then multiply everything by 2, then I'll get 5t squared minus 4t minus 9 equals 0. And that looks like it factorizes. 5t, t, minus 9, and plus 1. Yeah, that works. So t must be equal to 9 over 5. Okay. We've also got t equals minus 1, but we know that t is greater than 0. So that's not a solution. Okay, so it's just this one, t equals 9 over 5. And then finally, hence find the value of lambda. So we're just going to look at the equation involving I as well now. So on the left hand side we've got lambda, and on the right hand side we've got is equal to 2t squared minus 2t. But we know what t is now, it's 9 over 5. So if we just substitute that in, we get lambda is equal to 162 over 25 minus 18 over 5, which is the same as 90 over 25. So that's 72 over 25. Okay, question 3. Okay, well, this time we've given the acceleration and we want to find the velocity. So it's not that different to the previous question really. So we start by integrating. So we're going to get t minus 2t squared in the I direction And in the j direction, we're going to get 3t minus t cubed over 3. And then plus our constant vector. And this time our initial condition is that when t is equal to 0, v is 36i. So we'll substitute that in. And we get 36i equals c. So if we put that all back together, we've got v is equal to t minus 2t squared plus 36 in the I direction, and then plus 3t minus t cubed over 3j. So there's our general expression there for v at any time, and we want to find the velocity when t equals 4. So if we substitute t equals 4 into there, I've got 4 minus 32 plus 36, that gives 8 in the I direction. And if we substitute 4 into the second part, I've got 3 times 4 is 12 minus 64 over 3. So that's going to give minus 28 over 3, if I work that out. Okay, so that's the first part done. Second part, find the value of t at the instant when p is moving in a direction perpendicular to I. Okay, so if it's moving perpendicular to I, then what does that mean? It means it's only moving in the j direction. So the I component must be equal to 0. So all we have to solve is t minus 2t squared plus 36 equals 0. Let's put the squared term first and multiply by minus 1. I always find that makes it a lot easier to factorize if it does factorize. I think it does again in this case. So 2t t minus 9 plus 4. So we get t is 9 over 2. Okay, and that's the only solution. Okay, t is minus 4. Not a solution because we're told that t is greater than or equal to 0. So that's not a solution. So it's just this one. And then this part 2 of that question, at time t seconds, a particle q moves so that its position vector is given by this. Find the value of t at the instant when the speed of q is 5 meters per second. So we've got the position vector. I want the speed, so I'm going to have to find the velocity, so that we find that by differentiating the position vector. So we're going to get 2t minus 1 in the I direction. Remember, treating the i's and the j's just like constants, so nothing happens with them. So 3t differentiates just to 3, so 3 in the j direction. Okay, that's the velocity, but we want the speed, so I'm going to take the magnitude of that vector, and this is just a bit of Pythagoras. So I've got 2t minus 1 squared plus 3 squared, and that's equal to 5 meters per second. So if I square both sides, I'm going to get 2t minus 1 squared plus 9 equals 25. So 2t minus 1 squared equals 16. 2t minus 1 equals plus or minus 4. So 2t is equal to 1 plus or minus 4. Now again, t is positive or 0, so 1 minus 4 is going to give us a negative value of t, so we'll just take the positive sign there. So t is equal to 1 plus 4 over 2. Okay, so 5 over 2. Okay, that's it. Okay, the next one is a statics problem. We've got a ladder which is resting against a rod at C. It's also against the ground at A. We're told that C is smooth, so there's going to be no friction at C, but A is rough, it's rough ground, so there is going to be a frictional force there. So let's add on some of these forces. So at A, well, first of all, you've got just the reaction force of the ground pushing back up against the ladder. That's R. Because the ground is rough, then there must be a frictional force acting to the right. F, we'll just call it F, and that's equal to mu times R. And then at C, no frictional force because it's smooth, but there is still a normal reaction force. So we'll just call that Fc that we're trying to find. And the other force is the weight of the ladder itself. So we're told that the ladder has a mass m, so that's m times g. What else are we told? We're told that the angle is alpha, and we know that sine alpha is 4/5. So it's always useful to do this. So if sine alpha is 4/5, well, that's opposite over hypotenuse. So the opposite side is 4 and the hypotenuse is 5. And by doing a bit of Pythagoras, or just identifying a Pythagorean triple, we can work out that the other side is 3. So 5 squared minus 4 squared square rooted, if you want to do it that way. Once you've found the other side, then you can write down the other trig ratios. So cos alpha is adjacent over hypotenuse, so 3/5. And tan alpha is opposite over adjacent, 4/3. So we might need those later. Right. Now that we've done that, let's see what the question is. Show that the magnitude of the force exerted on the ladder by the rail at C is 9 mg/25. So we're trying to find Fc first of all. Well, there's 4 forces on there. So what I'd like to do is ignore a couple of them. So I can do that by taking moments at A. Okay, so I'm going to take moments around A. So I've got, what moments do I have? Well, clockwise, I've got the weight, the moment due to the weight. So that's force times the perpendicular distance. So what's this perpendicular distance here? Well, it must be 3A first of all, because it's halfway up the ladder, the weight, okay, because it's uniform. And then multiplied by the cosine of alpha. So we've got 3A cosine alpha. The other force is Fc multiplied by, well, let's just write down the distance. We'll just write that A to C. So we need to work out what AC is. Well, if we look at the triangle that goes A to C and then down to the ground, the big right angle triangle there, we know that that side is 4A, and we know that this is alpha, so we know that the sine of alpha, which is 4/5, is equal to opposite over hypotenuse. So therefore AC is equal to 4A over sine alpha. So that's 4A divided by 4/5, which is 5A. We also know cos alpha is 3/5, so we'll put that back in as well. So we've got mg 3A times 3/5 is equal to the force at C times 5A. So we can do some cancelling. We can cancel out the A's on both sides and then divide by the 5. So I'm going to have Fc is equal to mg times 3 times 3 is 9, and then divided by 5 and divided by another 5, so 9/25, which is what we want to show. That's the first part done. Hence or otherwise, find the value of mu. So now that we know that value, let's resolve all the forces in different directions. So first of all, vertically. So taking the forces up. Well, what am I going to have up? I'm going to have a component of that force at C. And if that angle there is alpha, then this angle in here must be alpha as well. So I'm going to have Fc times cosine of alpha acting up. I've also got the reaction force at A acting up, and that must be equal to the forces down, which is mg. So Fc, I know what that is. It's 9/25 mg. Cos alpha was 3/5. Plus R equals mg. So therefore R is going to be equal to mg into 1 minus, so what have we got? 27/125. So 125 minus 27 is 98, so this is 98/125 mg. So I know what R is now. That's good. So now let's resolve it horizontally. So horizontally, I've got the frictional force at A, mu R, must be equal to the horizontal component of the force at C. So that's going to be Fc times sine alpha. So if we put that back together, so R is equal to Fc, which is 9/25 mg, multiplied by sine alpha, which is 4/5, and then divided by mu. So 9 times 4 is 36, divided by 5 times 25, so we've got 36/125 mu mg. And so let's equate R's. So I've got two equations for R now. So I can say that 98/125 is equal to 36/125 mu. Okay, so obviously the mg's cancel. The 125s will also cancel. So mu is going to be equal to, if I just rearrange that, 36 divided by 98, which is the same as, if we divide top and bottom by 2, 18/49, and I don't think that cancels any further. No, because 49 is 7 squared, so that won't cancel any further. So there we go, we've got mu. Right, on to the last question. So the last one, we've got a ball being projected off the top of a cliff. We're told that the ball hits the ground at some point A over here. What else are we told? We've got the height of the cliff, 25 meters. So what we need to do first of all is we need to show that the initial speed was 28 meters per second. So let's just do some resolving using Suvat. So let's do vertically. So if let's take upwards as positive. So if we start at O and then we end up 25 meters below where we started, then if I'm taking upwards as positive, I've gone minus 25 meters. Okay, so I should just say I'm using this equation, S equals ut plus a half at squared. So u, what's u equal to? Well, that's going to be, so we want the vertical component of u, so that's u times sine 45 times t minus a half g. Okay, so again, if we're taking upwards as positive, the acceleration is negative because it's acting in the opposite direction, times t squared. We'll just leave it like that for now. We won't do anything more with that. Let's resolve horizontally as well. Now horizontally, there's no acceleration because the only force acting is the weight acting down. So there's no acceleration. So we just got basically distance equals speed times time. We know the distance is 100, and we know that the horizontal speed is u times cosine 45 times t. So what we can do is we can rearrange this one. We can say t is equal to 100 divided by u cos 45, and then substitute that back into the first equation. So I'll get minus 25 is equal to u sine 45 times t, which is 100 divided by u cos 45, minus a half g times 100 squared over u squared cos squared 45. So there's t squared. So let's just simplify a little bit. So I'm going to have u divided by u, so that cancels. It's good. Sine 45 over cos 45. Okay, so sine over cosine is tangent. And tan 45 is 1. So that cancels as well. Or the other way to think of it is that just sine 45 and cos 45 are both 1 over root 2. So they cancel. So all I'm left with there is 100. Then I've got cos squared 45. So that's 1 over root 2 squared, which is a half. So I've got a half on the bottom. I've also got a half on the top, so they cancel. And then 100 squared, so let's just write this. So that's 10,000 g over u squared. So I can rearrange this now. So first of all, 10,000 g over u squared is equal to 100 plus 25, so 125. So u squared is equal to 10,000 g over 125. Okay, and if we use g as 9.8, this, and so if we work that out and then square root it, then we get u is equal to 28. Okay, part B, find the greatest height. Well, we know at the greatest height, v equals 0. Okay, so the vertical component of v is 0, because if it reaches its greatest height, then it's not going to get any higher. It's going to stop and start coming back down. So let's use this equation of motion, v squared equals u squared plus 2as. So we got v is 0, u was u sine 45, and we know that that's 28 now for u, so we've got u 28 sine 45 squared. We'll take upwards as positive, so 2 times a is going to be minus 19.6, and then times s that we're trying to find. So if we rearrange this for s, we've got 28 squared times sine squared 45, and that's just a half, because that's 1 over root 2 squared. So we'll put a 2 underneath there, and then dividing also by 19.6. And if we put all that together, we get 20. So that means it's gone up 20 from where it started, but the question is saying, what's the height above the ground, NA? So the height above NA is going to be that 20 meters plus 25 meters, which it is above the ground. So 45 meters in total. Okay, then C and D, we're told now that air resistance is included. So first of all, part C, how would the new value of u that you calculate compare with 28? Okay, so if you think about it, it's still going to have the same range, 100 meters, but it's having to work against air resistance. So therefore, it must have been projected faster. Okay, if it has to overcome that and still end up at point A. So u must be greater than 28, as it must move faster to overcome air resistance but have the same range as before. And then part D, state one further refinement of the model that would make the model more realistic. Well, there's various things that you could put for part D. Maybe the most obvious one is use a more precise value of G, so 9.81 for example instead of 9.8. Okay, or various features of the ball. So you could think about the shape of the ball, the size of the ball. Those things would affect how the ball, the amount of air resistance that the ball feels, things like that. But probably that's the easiest one to say, just a more precise value of G. Okay, and there we are at the end of that mechanics section then. So hopefully you found that useful. If you did, please like the video and subscribe to my channel, where you'll find lots of other videos on maths and physics. If you want some one-to-one tuition, check out my channel. You'll find a link to my website, www.physicsmathstuition.com, where I offer one-to-one help. Okay, bye for now everybody.